Hello and welcome back to my channel. It's been quite a while, isn't it? In today's video, we shall be looking at this array of drawings which was carried out for a client. So the architectural drawings had been done by an architect, while the structural engineer is supposed to carry out the analysis and design of the structural elements. So from what we can see, let's start with the drawing here, or let me start with the notes. So we have some specifications that have been given for this drawing. So all these are meant to act as a guide for whoever is going to supervise the job on site. So we have instructions like the dimensions that are to be confirmed on site. Structural steelwork shall be mild steel according to BS 4360. And then the notes concerning welding, concerning concrete grade, even up to the soil bearing pressure, which was assumed to be 35 kilonewtons per meter square. Of course, that's a very low soil bearing pressure. And so because it's a low, it has a low soil bearing pressure. So there was a need to start up with a very good design for the foundation. So let's look at what we have here. So what we can see here is the ground beam. So basically your raft foundation is just like a slab, but in this case it plays the role of a foundation. So it's basically usually made up of depending on the design, made up of the beam and the slabs. So here we can see this is a ground beam. So we have different beams as per the design that was carried out. So if you look at what we have here, this is the first floor beam. Let's go and check. This should be the ground floor beam. So that's where we have our foundation. So our foundation is basically made up of a combination of beams and slabs. And so if we look further, we would see here that, let's start with this. So we have let's start with this one. So we have a ground floor slab. So you can see that the skeletal features has already been laid out here, this one, foundation. And so there was a need to include where the reinforcements will be for the slab. So after that ground floor, we now have the first floor. So we have all the detailing, displayed on this array of drawings. So the same thing also applies to the beams. So we have for the first floor beams, the floor beams, then we have the ground beams. So I've explained the ground beams earlier. So the question is, how can we draw all this? So let's look at the raft beams. Now, from what we can see here, the section of the beam has already been given, while the longitudinal section of the beam has been given, while the transverse section is here. So what we can see here, we need to understand this drawing before we repeat. Because for us, we are expected to have an understanding of this drawing and then be able to draw its section. So from what we can see, now we have, just like the normal beams, we have stirrups that will extend from this arrow point here up to this boundary here. The same thing applies to the boundary from the second span to this point, and then the third one spans from here to here. And already from what we know, what does T say? So it's just for us to have a better understanding. Okay, so T denotes high yield, high bond round reinforcement as per BS 4449 and 4481. So R denotes what? Mild steel reinforcement as per BS 449 and the millimeter size. So all the other ones will come up when we are dealing with detailing. The top lower level, the top upper level, the bottom lower level, bottom upper level. So let's go back to what we're looking at here. So from this ground floor beam, beam, let's look at this so that we can interpret it better. So let's go back, let's look at this. This one has just similar to the other one. What it means that from this point to this point, you have a total of 14 numbers of high yield stirrups. Okay, and the diameter is 10 mm, while the bar mark has been given as 17. Is that okay? So it has a spacing of 300 mm center to center. And so even if you look at it, so let's look at what we have here. You will see that this reinforcement, let me put this on. So So what we have here is that this particular reinforcement has already been labeled as 4T1618, meaning that we at the top bar here we have 4 numbers of reinforcement bars with 16 mm diameter, and the bar mark has been given as 18. Now, what does it mean? Let's shift the drawing. So let's shift it this way. So what we can see here, now the top bars, remember, it's extended from this end with the bent up bar and then up to this end, and the section was taken at this point, HH. So the top bar will obviously appear like this, meaning that there are 4 numbers of 16 mm bars. And don't forget, the bar mark has been given as what? 18. And that is why, so let's go back and confirm. So the bar mark is 18, and then the indicator here is that there are 4 numbers of 16 mm bars with the bar mark 18. Now, let's look at this again, because from what we can see here, the reinforcements, all the reinforcements extended from this end down to this end. So whatever information we can get from any of these other spans is valid for this span. So if we look at what we have here, from the second span, we could see here that we have 3 times 2 T1205. So what it means is that we are going to have 3 numbers times 2, meaning that if your beam, if you are looking at it from this section here, you are going to have 1, 2, 3 times 2, meaning that you have 6 numbers of it. So it should be at either edge of the boundary of the reinforcement, okay, of the stirrups. So the stirrups will be used to guard them up and position them in this kind of orientation. So it means also here, and this is what you must take note of, though you have 2 lines here to represent the reinforcement, but it means that between this point to this point there are 3 reinforcements on either side of the section. So it means that we have 1, 2, 3 on this section, on this part of the section, and then 1, 2, 3. So that is the explanation for that. Now this last point, the lower bars, what we have here is 4T16, and then it has a bar number of